Hi, my name is Mark Namarechwai and welcome to this video where we are putting everything together. Um, so when you start your data manipulation, you need to have a data which you need to import from somewhere, and the common sources are databases, cloud, which could be in the cloud or locally hosted, or you can import from your local computer, which could be Excel files, CSV files, text files, and many more. So if you have got R already installed, you just need to add the library dplyr. That is if you have already installed dplyr. If you don't have dplyr, well, that's fine, you can just install it. So I'm assuming that you have got your environment set, so you just run the library dplyr. Then I'm going to import the countries dataset which we'll be working with, and it's in my local computer, and this is the path. It's in the C folder, and this is the whole path, but the name of the dataset actually is this one which I've highlighted. If you can see here, this is the name of the dataset, and it's an R file. So I'm going to run it, and I've imported my dataset. Let me just clear my environment and re-import the data again. And I'm going to clear this. So it's like I said, the first thing that you need to do is to inspect your data. So if you put the shine, it's a comment code, a comment. You can comment that the code will not run when it gets to that part. Then you can look at the data dimensions using the dim. Then you can also look at the rows and the individual columns. Then you check for the data types that are there. Then you can see that this was all numeric data and some a double. Then we have got some character values there, Alabama, Metro, and so this data set, about this data set, let's look at it and just see the data set that you are working with. So this data set is about the census in the United States, and you can see the states, Alabama, New York, California, among others. Then you can see the county. In Zimbabwe, this would be like maybe a district. Then you can see the region, which maybe in Zimbabwe's case would be like, okay, the state could be like a province and a district, and maybe here it could be like a village, region, or whatever, I don't know. But yeah, I mean, we're just splitting down. Then you see the population, then you see the number of men and women, then you can also see the ethnicity, which is Hispanic, white, black, native, Asian, Pacific, citizen. Then you can also see if the people are citizens or not, then the income that they got, then the income per capita, then the income pay, then the poverty, child, professional or not, then the service, office, construction. So there are many variables, but we'll not be going over this, but I just want you to have an appreciation of the data, which you can do by pausing the video to understand it. Then I'm also going to leave the link there to give you the link to the file where they're hosted on Dropbox and YouTube. So let's go back. That's our data set. So if you've forgotten about the shortcut keys, you need your pipe operator, which is Control Shift plus M. Then if you want to run, you can use Control Enter or Alt Enter. The assignment operator is Alt minus. Then so what we want to do, the first code that you want to do, you want to use the select function to select columns, the county column, the state, the country, the population, and unemployment. So we see I've got selected, these are the 5 columns, and the table has got 31,038 and 4 columns. So it's always row by column. The number of columns are 4, which is the county, which is the state, population, unemployment, and let's see what happened to the county. County, yeah, it's the spelling, right? It's actually supposed to be like this. Oh, okay, I get it. This is the name of our data set. Then we have got the state, the county, which you have selected. So alternatively, what you can do, you can use the pipe operator, which is the one that way my mouse is hovering. um, you can use the pipe operator to do the same. You can achieve the same results. Then we also learned about the selector help functions, which we covered previously. Then these are the select helper functions. We can say everything which says, okay, first show me, the first column should be population, the second is metro, then keep everything as it is. Then you can also say select contains population, so that it contains population. It just look for POP, and if it's available, it will be extracted. Then you can also use starts with and ends with. Then we also learned about creating new tables or by assignment. So if the same thing, if I assign here, um, it will be assigned, right? So let's just delete this and say McNamara. If I do that, I've created a table called McNamara, and this is the table that I'm now showing you, which have got those observations, right? So that's basically it about creating new tables. Then you can view, you remember the view command, which you can use to view our tables. Then arrange, we covered arrange in the last chapter, if you remember, where we said we can arrange by the population, and we also covered the arrange in descending order. Then we also covered the filter function, where we said if it's a text, you need to put to put it in strings. Then we also learned about chaining methods, where we said you can say countries arranged by in descending order. Then you filter the state. I'm not going to discuss much about this, but if this is your first time, don't worry, there's a lot that we are going to cover at the end of the session. I just want to make this video very short because we have covered most of these things. But we have got county selected, arrange by population descending order, then filter unemployment when unemployment is less than 6. Then we have got again arrange in descending order, population filter, the state is New York, comma, unemployment is less than 6. Then we learned about the mutate verb. So we see here that if you go to where there's mutate them, we are saying create a new column from counties selected, create a new column called unemployed population, which is population times unemployment divided by 100. So if you run this code, okay, okay, I did not create this variable, so I'm creating it. You're going to see it showing here. So this is the variable that I've created, and you can see it's there. These are the columns in the variable in the table, right? It's a table with 4 columns: the state, the country, the population, and employment. So here we can arrange in descending order of population, which is, we see that California, Los Angeles has the most population. Then we can filter Texas, and we can see that it's now showing the results of the state Texas only. Then we can also arrange and filter. Then you see that the results are only New York, right? As you can see, we have got New York only. Then we can do multiple filtering as well for those that were less than 6. If you look at this column, unemployment, you see that the values that are there are less than 6. So I wanted to talk about the mutate verb. which we have already covered, but then it's good to revise. So county selected, create a new column called unemployment, which is population multiplied by unemployment divided by 100. So let's see if we've got that column created. Yes, we've got the column, and you see unemployment population in Alabama for this county called Tauga. It was 4,197, and for Baldwin the unemployment was actually, then for it was actually higher than that. Then we can also arrange this in descending order to see which state has got the highest unemployment. Then you also see that in California there are a lot of people who are unemployed. You've got 10 million people who are unemployed by the time of this census was done, which was 2018, I think. So we can also do some powerful summaries using group by and summarize. As you can see there, we have a summary of unemployment for each state. You can also, alternatively, you can do table using base R, and then if I say table, then table counties, then dollar, then state. You can see that we have got a table here of how many states that are in each county, right? So you can continue to change, but I'm not gonna do this because I've used table a very long time ago. Then alternatively, there's also a function called count, which you can use. You can then say count counties, then we put the weight is equals to, we can put the weight on the state, let's see how the result of this code. Then we also need to nna.rm is equals to true. Okay, so count is dollar state. Oh no. Okay, showing that this method has been deprecated, use group by, which is what we have done. But yeah, it will be nice. I think I'll look at this again when I'm. This is now old method, but so just remember these ones. But yeah, there's a way of actually doing this. But for the sake of progress, let me just do with what I have prepared, right? Let me just stick to it. So we can group by state, and then arrange in descending order of the average employment. So what we have done here, like I said, summarize can also be used to create new variables. In this instance, we are creating some total population, which is a sum of population. But what happens with summarize is called a window function, because no, not a window. It's called I'm forgetting the name. I keep forgetting the name. But well, what it does is that it retains one value. You can pass it a lot of values, but it just retains one value, right? So in this case, if you run this code up to this point, you're just going to get one value for each state. That's what the summarize will do, right? And it creates a column code here, average unemployment. But then you want to arrange it in descending order, right? So we see that now it has been arranged in descending order, and we see that Mississippi, in this case, tends to have the highest average unemployment. then we have done our selects already, but we want to chain it with a group by and state. So what will happen is that in the first instance, the group it will be grouped by state, then it will be grouped by metro, then the summary will be performed on obviously on the metro. So you can see here that Alabama is the highest. Alabama had two states. We've divided into metro and non-metro, and for each state you have got these instances of metro and non-metro, right? So if you also go into the data set and look at the metro, right? Let's close this seats counties. Let's look at the metro column. So the metro column is two variables, which you can also verify by saying we can then say distinct, then we say counties metro. If we run this code, no. Let's try unique. Yeah. So if we use unique now, we see that there's metro and non-metro. These are the unique values in that data set, right? So that's why we had that, right? Okay, let me just remove this code. It's not really important. We are going to cover these things when you do data cleaning in R. We are going to do a course called data cleaning in R, and we'll be looking at distinct values, unique. Then you also look for duplicates. Then we also cover like how you can perform reconciliation, how you can do which we call membership constraints. Yeah, we call them membership constraints. So let's not get ahead of ourselves. Let's just focus on these group by, summarize, ungroup, and all that. So in this instance, when you have done a grouping, which we have done here, right? So we have grouped our variables, but we cannot perform further analysis. We cannot chain further. Let's say we want to calculate the percentage or do some other function. We cannot. We need to ungroup it first, because if we don't do that, this calculations, our figures will be off. So let's proceed. We are saying group by state, sum, and ungroup, right? After ungrouping, the results will still be the same, but what you have done is, if this was Excel, would say we'd have killed the formula, right? So I want to introduce you to another verb called top n, which is very powerful. The top n verb is like, oftentimes businesses, executive, they want to know the top performing, the least performing. So you can use the top n verb to pick out those top performing. Because if I say top n 5, it will give me the first 5 instances of that. If this was grouped in this case, it will give me the first 5 for each and every state, right? So we are saying counties, select state, county, what we have done that. But let's look at this one. We are saying county selected, right? Group by the state. Then give me top n1 population. So one way of looking at this is, you can then say, where it's written 1 there, you can actually call it what n is equals to 1, which says that the number is equals to 1. And we're saying population, what you are doing is you are saying put the weight on the population. WT is equals to population. So it's the same as not removing. So the result that we get is this one. We see that the county Jefferson has got the highest what population, right? Then in Alaska, the county is called Anchorage municipality, is the one with the highest population. In Arizona is Maricopa. In Arkansas is Pulaski. In California is Los Angeles, which has got a population of 10 million, right? It's almost, the population of California is almost the population of Zimbabwe. This is very interesting, right? So we can do the same if you wanted to, like in this case, it will going to give me the two counties with the highest population, right? So let's repeat the similar code and see what we'll get. Right, it will give you two counties like with the highest population. So we have already covered this about the group by state. Top n is equals to 1, and I said wt is equals to weight. Then oftentimes you may want to say na dot remove is equals to true, right? But usually it happens when you have got some null values. The number of observations, right? Counties group by, we have done this, guys. We're just changing the weight to say if you wanted to weight on employment, we would just do the same and say this time you want to focus our analysis on employment, right? And this is what we get. Okay, so let's proceed. We oftentimes what you may want to do is the select function. We've covered that, the select function. Sometimes you can select a range. It's very powerful for quick analysis, where you say select state and pick this range. It will reduce the amount of code that you write. Then arrange, you've done that. So the helper functions, we have done them. Then the counties, select minus census ID, you're just saying select everything but remove census ID from the table. Then yeah, oftentimes you want to rename. So when you want to rename, this is the new item that we've got this county select, then we've got a verb called rename, which you can use to change the name of an object. For in this case, if you look here, we've got our state, country, population. If you look at my console, and unemployment. So what you are doing is you are changing this unemployment to unemployment rate. So let's just see if when I run the code, you see that I have changed my my column name. So I can also do this. It's still the same. Select in unemployment. It's still the same code. Like when you are renaming, so you can select and maybe change. You can put a pipe operator and use the rename in a different line for readability, because if this one is called direct assignment, right? Here, if you go to line to where my mouse is, you see that we have said select country, population, but we did direct assignment, right? Where we are saying unemployment rate is equals to unemployment. So if you choose to do this, you always need to remember that what's on your left side is the new variable name, then the old variable name is always to your right side. Or you can write clean code and still is always the right and the left side. Then you've got a powerful verb called transmute. Transmute is used for a combination. It uses select and mutate at the same time. So it returns a subset of column that are transformed and changed, right? So let's use transmute. So we've got on our counties data set, we are saying transmute state, country, fraction. Then we are creating a new column in the same line. This is very powerful, guys, and this is why people are moving away from Excel to R. And you never see someone moving from R to Excel. It's very, very rare, right? That's why people are moving from programming language like starter to R, and it's very rare for someone to move from R to starter or to SPSS, where you have to pay money, or Tableau. Yeah, of course, yeah. Anyway, I'm not here to do arguments I'm just here to demonstrate to you this data manipulation with dplyr, and how you can achieve much with very, very less code, right? So here we are creating a new variable called fraction mean, which is equals to the mean over the total population, right? So if I run my code, you can see here that I've got a new column um, called the fraction of men in each county, right? Okay, so we've got the state, the county, then we have got the fraction of men, right? So again, let's import another data set. Import data. So if you have got people who are expecting, this is a very interesting data set. It's called the baby names data set, and it has got the names of all babies that were born. What's the years? Is it 2008 from 1800? Okay, we can check. So here's my baby names dataset. So it's from 1880, right? And the last recorded name is 2015. So if you want to find popular names, let's analyze this data. So for you to see the data set, you can just run, and you can see that this is the. So if you want to filter a name, we can filter. In this case, we are filtering Emmy, and you see that the name Emmy in 1880 it was less popular. We see that there were only 167 Emmys which were recorded, and in 1885 it increased, right? And it's in 1925 the name increased. You can see that the numbers were improved. So we can actually visualize this. So this is where you need the library called ggplot for data visualization. Now I'm going to chain a lot of methods here, but this is very, very cool. This is why you need to learn R, and this is very, very cool. So what I'm going to say is I'm going to create a variable called baby names filtered, right? And this variable, if you look at it, it has got 28 observations, right? It says we are now tracking the name Emmy, right? And this is all the observations of the name Emmy from the beginning of the dataset to the end, right? So we are going to plot it. So we are going to say ggplot. We are going to do ggplot covering ggplot in data visualization, but for now I'm just going to just give you a basic appreciation of ggplot. What you need to do for ggplot, you just need ggplot. Then what you need is the data, right? After the data, which you can say the data equals to in this case our data is equals to the baby names filtered, right? Then comma. You also need what you call aesthetics, right, which is the x and y's, right? So it's called AES, right? Then in the aesthetics, you pass in what you want to be in your x-axis and your y-axis. So I'm just going to copy this and paste it there, right? Then you also now add a geometric object, right? So in this case, you're just going to say plus a geom line. We want a geom. So there are many geometric objects like geom absolute line, which we tend to use it in statistics. Then geom bar, geom the box plot, geom column, geom counter, geom crossbar, geom curve, geom density, geom.plot, geom error bar, geom frequency poly, geom hexa, geom histogram, geom jitter, geom label, geom line range, geom map, geom point, geom polygon, geom QQ line. So there are many geom objects that you can create, guys. There are so many to learn on data visualization, right? Like you can actually go to a meeting with one data visualization and explain and spend 1 hour describing that, that data set, that doing your analysis. I'm just trying to tell you that there's so much that you can achieve. So in this case, you're using a geom line, right? A geom line, right? Then close. So that's basically what you need for you to do a ggplot, right? Those are the main ingredients of a ggplot, right? So we can see here from this diagram that I've plotted. I'm going to increase it, right? So we can see that the name Amy actually, um, in the 1980s, it was very less popular. That increased in popularity steadily. um, then it had a fairly high increase in the 1920, fairly high popularity in the 1920s, which dropped up to the 19 between 1920 and 1950. Then we can see that from the 1950s there was a sharp increase in the name Amy. I think there was a queen who was named Amy, or something happened, because it actually peaked here in the 1970s. Then we see that up to the 2000s it has dropped in popularity, but it's still used, right? um, so yeah, that's about the an analysis though. So when you start to do visualization, as you can see, the maturity also of your analysis increases. So that's it. So we said for ggplot you need the ggplot, then you need the data set. This is a shortcut of the code that was up there. Then you need some aesthetics, then you need a geom line, right? That's basically what you need, right? Okay. So yeah, I expected that because we didn't put in so this is the what you need is the aesthetics and the geom line. So maybe let me return my code, yeah, because I already completed it. And maybe we can start with this item that shows what the ingredients for ggplot. um so here we're just going to say the data, right? Then we can also filter multiple names. We have covered this where we're saying baby names. We want Amy and Christopher, and we want to compare these two, right? So we've got a, if you go to my environment there where I'm hovering my mouse, we see that I now have got a new data set called with Christopher and Amy over the years. So I can actually uh, track these two guys, right? Um, so um, if we take this data set and say copy and paste it here, right, and run this code. Okay, then okay, let's proceed with our code. So here we what was each name's most common. So we remember we used the the top end verb to say we can say n is equals to say how much do you want. Then you can say the wt equals to, and this is going to give us the okay the answer that we want, right? So you can see here that the name Emmy, if we look at this, it just goes to show you like when the name was most common, right? To say in 1980 the name Ark was 61, and the name Bad and Edna and among other names. You see how they performed over the years, right? So this was just to show you like the weight, and but I'm going to remove this so that you can keep practicing, right? Then let's look at grouped mutates. We want to use group by and summaries, which we have already done. So we are going to group by the year and summarize the number, right, of baby names. So what we then get is we see that in 1980, how many names do we have? We have 201,000, and in 1995, so we just see that also the population is increasing. Then we can combine group by and mutate. So if we do that, we are saying group by the year and create a new column called year total, which has the sum, the year total, which have got the yearly total, right, for all the names, right? So let's proceed with our analysis. So you remember, if you want to continue chaining this, we need to ungroup it, right? So we have ungrouped it. So we can now do further computation by adding a mutate and calculating the fraction of how each name performed each year, right? So as you can see there, this is the fraction of each and every name as a percentage of the total population, or of the total names, right? Then we've got what you call window functions. So I'm going to show you what a window function does, right? Then so we've got create a vector code which has got 4 numbers, 1, 3, 6 and 9. So if I call this vector to print it, you can see it has got the numbers. If I say leg v, can you see what's going on there? And so what leg does as a function is that it retains the difference between the previous and the next observation. It's very powerful when you want to do like mature analytics. So if I say v minus leg v, right, what do you have? It now becomes a cumulative leg, right? Okay. If I say leg v, we did that and we saw this. So what we are doing is we are saying 3 minus 2 minus 1, we get 2. 3 minus 2, we get 6. Then 18 minus 4, we get this, right? So I've got already dplyr installed. So what you're going to do is, we had done this already, but we want to do some powerful analytics we've done for Matthew over time. We want to look at Matthew's performance over time, right? So we just showing you that you can filter the name Matthew and arrange it by the year, right? So let's do that so that you can see how this whole code is playing out. let's look at this variable called baby names fraction. Baby names fraction. Right. So this is the fraction of the baby names. So what we want to do is we are saying baby names fraction filter Matthew. So if you filter Matthew, we remain with the fraction of Matthew. Right? We've got the fraction of Matthew. So what we are going to do now is we want to arrange it by year and mutate. We want to create a column of difference and see what has happened, the changes that have happened to that name over time. So we see that in 1985 the name Matthew decreased in popularity, and so we can see that in 1995 it increased, right, among other things, right? So we can also track to say which year had the biggest jump, right? So if you want to do that, we just add an arrange to our verb, and we then see that the year that the name Matthew became very popular was 1975. Okay, so if you look at those years, you find that somebody popular was called Matthew, or there was a big movement in evangelism that caused that push, right? So we can also say changes within every name. So if you want to track the every name, we will say baby fraction arranged by name and year, then mutate the difference is equals to fraction minus uh, leg, right? Okay, let's see something here. Okay, okay, so we've got this column called fraction, right? So what we're saying is fraction minus the leg of fraction, grouped by the name, then arrange in descending order. It will give us the change of every name. So guys, once you have done this, you have come to the end of this course, data manipulation with this plier. I wish you all certificates and to that you complete and get your certificates, so you can get in touch with me. I can help you. But over and above, it's just good to get this knowledge of how data science begin, how you can automate stuff, and how you can quickly give results to business, because business wants results ASAP. Don't spend 2 days doing an analysis. Don't spend a lot of resources, company hiring many people to do an analysis. You can do this once you use the right tools. So thank you and bye.